Hello friends, welcome back to my channel. Let's jump into a quick discussion. What happens when a complex exponential is applied as an input to an LTI system? So let's find it out. So I have an LTI system here, and if I give x of t equal to e power j 2 pi f naught t, which is a complex exponential, as input to an LTI system, what would be the output? That's the question. To find out the answer, we rely on two representations of the LTI system, which is nothing but the impulse response h of t and its corresponding frequency response h of f. Now let's go back to the question. What is that? Given x of t equal to e power j 2 pi f of naught t, it is passed through LTI system. What is the output? Y of t. Because it's an LTI system, the output can be written as convolution of the input x of t and the impulse response of the system h of t, and this in integral representation is given in this form, which is integral minus infinity to infinity h of tau x of t minus tau d tau. Now let us substitute this x of t in this. Means what? Wherever there is t, we have to replace with t minus tau. So what do we get? Integral minus infinity to infinity h of tau e power j 2 pi f naught times t minus tau d tau. Now this, because this integration is with respect to tau, we can bring out e power j 2 pi f naught t out, and finally we get y of t equal to e power j 2 pi f naught t multiplied with this integration. But e power j 2 pi f naught t is nothing but our input x of t, and hence that y of t would be equal to x of t multiplied with this integral. But we know that this integral is nothing but the Fourier transform of h of tau evaluated at f naught, and hence we can write it as h of f naught. So what is the final output? That would be equal to the input x of t multiplied with h of f naught. This h of f naught is a complex constant which can be a function of f naught. So what is that we have seen? If you pass an input x of t through an LTI system, and if the output is of this form, y of t equal to k times x of t, we call this special signals x of t as what? Eigen functions, and the corresponding constant or the scaling factor k, which is a complex value, is we call it as an eigen value. So we just proved that e power j 2 pi f naught t is an eigenfunction of LTI system. But are there other signals that can also be eigenfunctions? Please explore further. And lastly, is there any analogy between these eigenfunctions and eigenvalues of a matrix? Think about it. Thank you.